All right, so now we're going to talk about the perfect square. And to understand how to factorize the perfect square, we need to appreciate where the perfect square comes from. A perfect square would be a binomial where you multiply it by itself. So for example, look at this, x plus 3 squared. X plus 3 squared will be x plus 3 by x plus 3. This essentially is what a perfect square is. When you factorize a perfect square, you'll get two identical brackets multiplied by each other. Hence the term perfect square. Because if we say 2 squared, we know we're multiplying 2 by 2. 3 squared will be 3 by 3. So we could get brackets that are squared. Now, there's a pattern when we square brackets. Look at this pattern, right? We'll do a couple examples. X by x is going to give me x squared. X by 3 is going to give me plus 3x. And then 3 by x is going to give me plus 3x. And then 3 by 3 is going to give me 9. So I am going to get x squared plus 6x plus 9. Right? Keep that in mind. We're going to do another one on this side here. If we have x plus 4 squared, that's going to be x plus 4 by x plus 4. Now let's look at what happens when we multiply x plus 4 by x plus 4. So x by x is going to give me x squared. We saw that before. X by 4 is going to give me 4x. 4 by x is going to give me 4x. And then 4 by 4 is going to give me 16. So now I'm going to get x squared plus 8x plus 16. I'll do another example. Look at x plus 5 squared. You're going to get x plus 5 by x plus 5. X by x is going to give me x squared. X by 5 is going to give me plus 5x. And then we're doing 5 by x to give me plus 5x again. And then 5 by 5 to give me 25. So I'm going to get x squared plus 10x plus 25. Right? Now, I'm going to use some generic terms now. Look at this. First, identify the pattern. Let's use A and B. So if we have A plus B squared, that's going to be A plus B by A plus B. A by A giving us A squared, and we've seen that with the x squared. Then we're going to get A by B. That's going to give us AB, just like how we do 4 by x, and then x by 4. And then B by A would give us the same AB. B by B will give us B squared. So what is happening when we have a perfect square is that we're going to have our first term. In this, all of these, the first term here in the bracket is a x. We'd always get x squared. The last term, so this is my A, this is my B. This is my A, this is my B. This is my A, this is my B. Look at what's happening. This is A squared. This is 2 by A by B. And this is B squared on this side. Watch again. A squared plus 2 by A by B plus B squared. Look here again. A squared plus 2 AB plus B squared. What is A here? A here is x. So we have x squared. What is B? B is 4. So 2 by x by 4 is giving us 2 4s are 8x. Everybody see that? Look at it here. A is x. B is 3. So 2 by x by 3 is giving me 6x. Look here again. A is x. B is 5. So 2 by x by 5 giving me the 10x. So there's a formula. The perfect square, when we want to factor the perfect square is always in the form a squared plus 2ab plus b squared. This is the format for a perfect square. And a perfect square will always factor to be AB by AB. Or in other words, AB squared. The same bracket by itself, squared. Everybody understand that? So, understanding it is one thing. We have to be able to recognize it, right? And that's what we want to look at. We want to be able to recognize it. So, let's look at some examples. All right, so let's look at recognizing the perfect square. If we have a quadratic, for us to be able to recognize the perfect square, we're using our understanding, the formula for the perfect square, which is a squared plus 2ab plus b squared. So we could take that quadratic and we could say, okay, if this is a squared, then a here is going to be x, right? Because the square root of x squared is x. And then if 36 is b squared, then b is going to be 6. Right? Everybody agree with that? And then this is our test here. We want to check the value of 2 by a by b. So 2 by a is x and b is 6. That's going to give us 12x. If this happens here, then we know that this is a perfect square. And we know that our values for a is x and b is 6. So remember, with a perfect square, we're going to get a plus b by a plus b. Our a value is x and our b value is 6. And it's been multiplied by itself. So in other words, what we have is x plus 6 squared. Everybody understand that? Right? So you have to test it. So let's look at another one. Let's say we have x squared plus 14x plus 49. Your first clue should be that this last number here is a perfect square. This is 7 squared. And where we know this is a square because it's already squared. And it means, therefore, that my a value, if this is a squared and this is b squared, then a here is going to be x and b here is going to be 7. And if I check in the middle, 2ab, and I get 2 by x by 7, and I could get back that 14x, we know that this is a perfect square. So to factorize this, we know it's going to be x plus 7 by x plus 7. So it's all about being able to recognize it. And if you could recognize it and discern what a and b is, then factorizing it is going to be easy. Because it's based on a pattern. Yeah? Now, your clues for using this method is 1, the expression that you're trying to factorize is a quadratic expression like this. 3 terms, descending powers of x with the highest being x squared. Yeah? The other clue you're looking for is this term at the end being a perfect square. And then the last thing you're looking for is that your AB, your 2AB in the middle is actually the product of whatever A is and whatever B is multiplied by 2. Everybody understand that? So the most important thing is that for a perfect square, to be able to recognize a perfect square, we need to remember that the format is a squared is equal to 2ab plus b squared. Let's look at a slightly more complicated example. Let's say we have 4x squared plus 25. And in the middle here, I have this one slightly more challenging to identify. But remember what I told you, looking first is our quadratic. Second thing we're looking for is that this last term here is a perfect square. So this is my b squared. This here is my a squared. Now, after you do that, you want to know what a is. So if this is a squared, then a has to be 2x. Square root of 4 is 2. Square root of x squared is x. Square root of 25 is 5. And then we're going to check our 2ab value. So 2 by 2x by 5. Yeah, it's off a little bit. Right, we get 20x. 2 by 2 is 4. 4 by 5 is 20x. Right? Should have put 20 there. That was my bad. And that's how we determine that this is a perfect square. Follow? All right, now we want to talk about the difference of two squares. Again, similar to the perfect square, this is not something that you have to work out. It's more pattern recognition. So I'm going to write a number of examples here of difference of two squares, right? And then we factor them after. So this is one. This is another one here. This is another one here. Oops, no. This is another one here. Do one more, squeeze one more here again. Right. So clue. Two terms, both perfect squares. Right? Can be written as a squared minus b squared. And your formula, or how we're going to work it out, is once you could write it as a squared minus b squared, the answer is always a plus b, a minus b. Let's see if we could write these as a squared and b squared. This is already a squared. I could write this as 2 squared. And that makes it b squared. So I could rewrite all of these as the difference between two squares. Everybody see now? So once this end number here and the beginning number are perfect squares. A perfect square is a number that when we find the square root of it, is not going to yield a fraction or remainder or decimal part. It will be a whole number value. Right? So like the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Right? You know all your squares. Once we could identify that we have the difference of two perfect squares, then we know that it's the difference of two squares. And our answer is always going to be, if this is our A, right? A is going to be X here. B is going to be 2. A is going to be X, B is going to be 3. It's not going to be the 9, it's going to be square root of the 9. A is going to be X, B is going to be 4. A is going to be X, B is going to be 5. A is going to be X, B is going to be 6. So if we have A plus B and A minus B, then my answer here will be X plus 4, X minus 4. Here, X plus 3, X minus 3. This one, X plus 2, X minus 2. See that? That's why I said there's nothing really to work out. It's all about recognizing the pattern. Once you recognize the pattern, then the answers are simple. Just kind of write the answer. Everybody understand that? All right, so let's look at the solutions for these. So from the time you're seeing, you have to factorize something like this, right? The question would say factorize. You're only seeing two terms, x squared minus 64. From the time you see two terms, then you see the minus sign in between. The next thing you should be checking is to see, all right, are these two perfect squares? Anytime we could do this, x squared minus 64. And you could write these as some number squared, right? Well, the x squared already squared. But 64 squared is 8 squared. This clearly is the difference between two squares. You can see that there are two squares and the difference, it means subtraction, minus. So we will write x plus 8, x minus 8, right? So again, you're looking for a pattern. It's a pattern recognition. You see in two terms, you ask yourself, can I write these things as perfect squares? Let me look at them. 16 is 4 squared, and x squared, and 9 is 3 squared. I could actually write this as the difference of two squares. I could put, since both of them are squares here, I could put this in a bracket. And you could clearly see this is the difference between two squares. So I will write 4x plus 3 and 4x minus 3. And last one here, we have 100 x squared minus 25. We could write this as 10 squared. This is our x squared, and this is our 5 squared. We could put these two in our bracket. We don't need to write the two squares there. And then clearly this is the difference of two squares. So we get 10x plus 5. Right out of that. So. And 10x minus 5. Yeah? And that's the difference of two squares, factoring the difference of two squares.